Good morning, everyone, and welcome to the second session on lakes. This time the focus is the small lakes scattered around the Irish landscape. You can see on the map on the left the distribution of all the lakes in Ireland. You can see there's a very large number, but that they're associated with certain areas. For example, Galway, Mayo and Donegal have a very large concentration of these small lakes. A second concentration is in the Drumlin Belt in Ireland, from Strangford Lough in the northeast to Clew Bay in the west. And there's a scattering of lakes along that so-called Drumlin Belt in Ireland. Those lakes were formed after the melting of, or during the melting of the ice sheet, just under 10,000 years ago. As the ice sheet broke up, large, medium and small blocks of ice were separated and existed for some hundreds, maybe up to 1,000 years. They compressed the boulder clay underneath and hence formed the basins of these many hundreds, indeed a few thousands of lakes. The landscape is dominated by small lakes, and you can see in this chart the density of lakes in 4 categories: the 1 to 10 hectares, 10 to 100, etc. And you can see that the density of lakes, particularly in those middle 2 categories, 10 to 100 and 100 to 1,000 hectare lakes, is as high as in Sweden, which is a country well known for its lakes. So that's the focus of this presentation. We've been monitoring lakes in Ireland for quite some time. You can see here the front cover, very early survey of most of the important lakes in Ireland. You can see it's dated May 1975. So there's been work on lakes since then, but a lot of the change in these lakes has taken place over a longer period of time, for which we can use the environmental record in the lake's sediments. You can see a sediment core on the left here, and if it's sliced up and properties in these slices measured. And the ones we show in here are the phosphorus concentration at those various times in the past, inferred from a group of algae called the diatoms, the remains of which are buried in this sediment. There's 3 of these interdrumlin lakes here: Ballywillen in East County Down, Brantry in East Tyrone, and Corbett in Central County Down. But these are typical of many of those interdrumlin lakes. While the concentrations differ, the pattern is the same, which is after around 1950, the concentrations rose substantially. And that pattern is found in many lakes in Ireland and elsewhere. That increase in phosphorus and other nutrients, for example nitrogen, is called eutrophication. And it's a handy term to describe the biological effects of nutrient enrichment in lakes. It's really like the gardener or the farmer adding fertilizer to the lawn or the field. The excess or the additional nutrients grow more grass, and exactly the same happens with lakes. These are photographs from another interdrumlin lake, Castledillon Lough, just outside Armagh. And on the left-hand photo, you can see great growth of algae. Again, it's like adding fertilizer to your lawn or your field, and it grows much more grass. So this lake has been over-fertilized. On the right-hand photograph shows the larger plants. These grow in the shallow waters of the lake and around the margins. You can see floating pondweed there. And again, that's due to, I suppose, excess fertilization of the lakes. The species also change, different species of algae and plants, and you get different species of insect larvae and eventually fish. At the end of the year, of course, all that organic matter has to decompose. And an important effect of eutrophication is the consumption of oxygen during that decomposition of the algae and plants in the autumn time. And this can be shown in another interdrumnal lake, Ballyduggan Loch, near Downpatrick. It's a lovely typical interdrumnal lake. It used to have a little pub on the side of the shore. Remember those rural pubs? But you can see on the two charts here, or you will see in these two charts, the variation of oxygen on the right and temperature in the middle, how those properties change with depth over the spring period, April through mid-May. Keep an eye on the chart on the right particularly, and you will see the oxygen concentration begin to drop, particularly towards the end of April. Okay, so this is the beginning of April, moving through weekly. By the end of April, you can see there that the oxygen concentration, this is in the chart on the right, in the deeper layers of water is beginning to get quite low. And as we move through to the end of May, the oxygen concentration is depleted at about 10 and 11 meters depth. And that's due to the organic matter from the algae and plants in the sediment consuming oxygen. And that continues right throughout the summer. And an important consequence of this is the release of phosphorus from the sediment of the lake into the water column to accelerate the over-fertilization of the lake. Not all lakes behave in this way, of course, but some do, and this accelerated eutrophication through the phosphorus being released from the sediment into the water is an important aspect or cause of that. We should note before we move on that today, under the umbrella of the Water Framework Directive, the quality or the status of lakes is determined by the plants and animals you find there. It's based on, at the top, the algae, and on the right, those plants that grow in the shallower waters and around the lakes, and at the bottom, the insect larvae found in the sediment, and on the left there, the fish that you find. So using the species and amounts and composition of all of those plants and animals, your lake is classified into one of three classes here: high and good at the top end, and poor and bad at the bottom end. And the objective of the directive is that all lakes and rivers, for that matter, achieve at least good quality or good status. Well, you know that already that over-fertilization, particularly with phosphorus, is a cause for the deterioration of lakes. And so the way to improve the quality generally is to reduce the loss of nutrients, particularly phosphorus, from the catchment into the lake. And the same applies to rivers. There are other reasons for a drop in quality, but this is definitely the major one. The sources of phosphorus and hydrogen in catchments varies a lot. The important source, of course, are some or all of these, or most of these. Wastewater treatment works from your local town small rural works, rural water treatment works. Of course, there's septic tanks as well. Runoff from farmyards can, on occasions, contribute. Slurry spreading, maybe at the wrong time of year. And of course, over-fertilization of fields or excess fertilization of fields. You've had a glimpse of that in Julie's presentation first thing this morning. But not all lakes are amenable to, are able to be improved through reduction in the loss of nutrients from the catchment to the lake. There are some difficult lakes, and they've either got no outflow or they've got a substantial store of phosphorus in their sediments. You can see here this map of lakes. They're just in Northern Ireland. It was part of what was called the Northern Ireland Lake Survey around 1990. And of the 615 lakes in the survey, about a third had no outflow. So even if you reduce transfer of nutrients from the catchment to the lake, there's no way that those nutrients can, that are already in the lake can be lost from it. So those are difficult lakes. And then if the enrichment of lakes has taken place over some period of time, a few decades to 40 to 50 years, then you can get a build-up of phosphorus in sediment. And the two examples here are on the left from Loch Ness and on the right, Loch Ramor in County Cavan. And you can see the concentration of phosphorus is higher, particularly with Ramor, much higher in the upper sediment layers. And that sediment can be recycled, as you saw in Ballywillan earlier, during deoxygenation in the water or in the sediment. People have tried to improve these sorts of lakes by dredging out that sediment or aerating the deeper waters to try and prevent that deoxygenation and loss of phosphorus from the sediment. But by far the most widely used technique to improve the quality of these more difficult lakes is fixing the phosphorus in the sediment by adding some chemicals, usually salts and some metals. These salts bind chemically to the phosphorus and immobilize it or fix it in the sediment, preventing it from being recycled and enriching the lake. Aluminium salts are the most widely used, and you can see there they have been used commonly in North America, the USA, and Canada from 1970, since 1970. And now in Europe, with people striving to meet the objectives of the Water Framework Directive. And you see quite a few lakes have been treated, and that list would be longer today. The other widely used salts are salts of iron. The use of these is being more recent, and you can see there's perhaps fewer examples of the use, but they are effective as well. And I've noted there that back in 1980, Whitelock in South Tyrone, just north of Auchnacoy, was actually treated with iron salts. And you can see in this chart the variation of phosphorus concentration over time. And in the 70s, the concentration rose quite high. The lake became much more enriched, and it was felt that it needed to be treated with iron. And it was, but it was considered to be unsuccessful. But that really wasn't the case. The lake became enriched and then recovered naturally itself. And it was due to the warm and dry period in the mid to late 70s, causing a natural enrichment of the lake. So it really didn't need to be treated. So within catchment care in the lakes work stream, with those difficult lakes, the options were to improve their quality by either using aluminium or iron salts. There wasn't much in it, but we chose aluminium salts based on stronger evidence for their effectiveness and how long the improvement lasts. And also the aluminium salts were a little bit cheaper. As I've mentioned, these salts, particularly aluminium, are widely used, but to build up confidence as much for ourselves, but also for others, that they be used safely to improve the lake without affecting plants or animals, we completed 2 large pieces of work. Within catchment care, we selected and monitored 5 lakes, 5 difficult lakes, which could be improved by fixing of phosphorus in the sediment through the addition of, in this case, aluminium salts. So we monitored them for just over a year, and you can see here just one of the properties we measured, the phosphorus concentration. These are quite high and vary through the year, but particularly increasing in the summer and early autumn. And to pick out 2 of them, Corcacan and Cray, you can see that the concentrations rise substantially in the summer and early autumn. And that's due to the release of phosphorus from the sediments. We also used these monitoring results to estimate the dose of aluminium salts that would be required to improve the quality of the lake. And you can see in this table the annual mean concentrations of phosphorus and the associated aluminium that will be needed to improve the quality of the lakes. The range is 0.6 to 1.3 milligrams per litre as a dose, so around 1 milligram per litre, you could say. Another method for estimating the dose is to look at the phosphorus in the sediments. You can see in the central photograph a gravity core of sediment from one of these lakes. That short core sediment was sectioned into 1 centimeter slices, the phosphorus concentration and the available phosphorus concentration determined. The available concentration is the amount that potentially can be released from the sediment to enrich the lake. So those concentrations can be used to estimate the dose based on the sediment. So looking at the estimates based on the water column and in the top layer of the sediment, the range is 0.6 to 1.8 milligrams of aluminium per litre. But if you scan the numbers, you can keep in your head around 1 milligram per litre as a dose. So as I've already mentioned, the use of aluminium salts to improve lake quality is widely used, but as much for ourselves as others, we completed 2 pieces of work to provide evidence that the lake will be improved without damaging any other plants or animals. And so we completed a formal risk assessment where we brought together and assessed the toxicity test results for aluminium for a range of lake animals and fish. And from that analysis, a protective threshold of 3 milligrams per litre aluminium was derived, a little bit above the dose of around 1 milligrams per litre. But we felt strongly that real-world evidence where people had treated lakes and monitored the effects, the ecological effects, would be better evidence that little damage would be done to the lakes. So we collated results from 9 whole lake case studies. And this is just the top part of the table. And the strong findings from those case studies was that there was almost no ecological effects. You can note that the doses in these lakes were much higher than the doses that were needed for the catchment care lakes. The average concentration used was just under 6 milligrams per litre, substantially higher than our 1 milligram per litre dose. The only ecological effects were only in one lake, and only with some of the species, a temporary increase in the aluminium concentration in the gills. In addition to the generic risk assessment, local risk assessments would be needed. And we have a general set of rules to apply. And if you apply them to Grove Loch, then you would examine the uses of the lakes. This is occasionally used for water supply. There's coarse angling and livestock drink from the lake. Maybe there's risks downstream from the lake. There's no well-defined outflow to the lake, so they should be low. It'd be important to liaise with landowners and others that use, for example, Irish Water or Monaghan County Council, Law Pro as well, and any local anglers. That would be important to involve them and keep people informed. How would the salts be added to the lake? It's relatively simple, and using Grove as an example, 230 litres of the salt would need to be distributed over the 1 hectare of the lake in about 30 minutes to achieve that dose of around 1 milligram per litre. The salts would be pumped over the back of the boat in and around the propeller to mix them very quickly with the lake water. And moving around the lake in a zigzag pattern over 30 minutes would distribute the dose appropriately. We felt it important to monitor the lake, and after remediation, firstly to establish improvement in the quality, and also to provide evidence that there was no damage to other parts of the lake. There would be 2 elements to the monitoring: baseline monitoring beforehand of chemical properties and biological properties. The chemical samples would be taken every other day for 5 days. And amongst other things, the aluminium concentration, the phosphorus concentration, and the green pigment in the algae, chlorophyll, would be measured. The biological components would be, again, every other day for 5 days. The zooplankton collected by that tow net, vertical tow net that you can see in the second photograph from the right. And then on the photo on the right shows gill netting of fish, and they would collect 3 to 5 specimens of the main fish species for measuring the aluminium concentration in their gills. We're awaiting approval for collecting fish from called a Section 14 license, and also we need some approval from a scientific animal unit as well. And after dosing, then the post-remediation monitoring consists of the same properties, but for extended length of time. On the chemical side, it will be samples every other day for 8 days, weekly for a month, and then monthly for a year. On the biological side, again, we would collect the zooplankton every other day for 8 days, weekly, and then monthly for a year. And the aluminium concentration in the gills are the main species, a week after remediation, a month, and 2 months. As I mentioned, we're waiting some approval so we can sample the fish. Hopefully we will get that. And if so, then our plans for the rest of the catchment care project is to remediate and monitor Grove and Greylock later this year, and Corcacan and Lambs early in 2022. So those are our plans for the future, and we hope they come to pass. Thank you.